Hello and welcome to 10.4 Notes. Today we're going to discuss the relationship between inscribed angles and intercepted arcs. So first, let's talk about some definitions. Okay, an inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. So this is the inscribed angle, okay, and its vertex right here is on the circle and its sides contain chords, right? These are chords of the circle. So this is called an inscribed angle, okay? And the arc that lies in the interior of an inscribed angle and has endpoints on the angle itself is called the intercepted arc. So this here is the intercepted arc, okay? And you'll be responsible for this theorem here. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. So this is the inscribed angle, and it is 1/2 of the intercepted arc. So if, for example, this was 10 degrees, this would be twice as much. It would be 20 degrees. And if this is x, this is always going to be 2 times that value, 2x. In degrees. So, of course, if this was, say, 150 degrees, this would be, the angle would be half that. It would be 75 degrees. Okay? So, the measure of angle ADB is going to be 1/2 of the measure of the intercepted arc. Okay? All right, and how will this be used? Well, please copy down this prompt, this circle here. And again, if you need to stop this presentation and pause it, fast forward, rewind it, of course you're in total control. You're in total control of this presentation. You can do as you please. But for the sake of this presentation, I will continue. Okay, so the question is, what is the measure of arc AR? Well, the inscribed angle is 25 degrees, and we want to know the measure of arc AR, which is the intercepted arc. The intercepted arc is going to be twice the value of the inscribed angle, therefore twice 25, of course, 2 times 25 is 50 degrees. So the measure of arc AR is 50 degrees. Okay? All right, and then we have this theorem here. It's if 2 inscribed angles of a circle intercept the same arc, then the angles are congruent. So we have 2 angles, right? These 2 angles here, and if they intercept the same arc, which they do in this case, they both intercept arc AB, right? You have this angle intercepting arc AB, and you have this angle intercepting the same arc, arc AB. Okay, so that means that the measure of angle ADB is congruent to the measure of angle ACB. These 2 angles have to be congruent because they're intercepting the same arc. Okay? And another theorem that has to do with intercepted arcs is if a right triangle is inscribed in a circle, then the hypotenuse is a diameter of the circle. Or conversely, if one side of an inscribed triangle is the diameter of the circle, like in that case, it is the diameter of the circle, then the triangle, this triangle, is a right triangle, and the angle opposite the diameter is the right angle. Okay? And yet another way of saying it is right here. If the measure of angle ABC is 90 degrees, okay, if this is a right triangle, if ABC is 90 degrees, then line segment AC must be a diameter. Okay? And since AC is clearly a diameter, right, because this chord is going through the center, so it must be a diameter, then this must be a right angle. Must be 90 degrees. So what it's basically saying is, if you have a diameter, or if you have any triangle written inside of a hemisphere, or half of a circle, I guess I shouldn't say hemisphere, but half of the circle, right? If it's drawn in like this, hold on, let me change that. If it's, say, like this and like this, right, an angle within the half of the circle, like this angle, this must be a 90-degree angle. This also must be a 90-degree angle. Okay? So this is a 90-degree angle, this is a 90-degree angle, this is a 90-degree angle. Any triangle that you put inside of a half circle is going to be 90 degrees. So all of these, right, looks kind of pretty, looks kind of like spirograph. All of these here are going to be 90 degrees. That's 90 degrees. That's 90 degrees. That's 90 degrees. That's 90 degrees. All of these are 90 degrees. Okay? And also, of course, on the other half of the circle, this would also be 90 degrees. Okay? Does that make sense? And then the last piece of information you'll be responsible for is, if you have a quadrilateral inscribed within a circle, like in this case you have this quadrilateral, quad means four, lateral is side, any four-sided figure, any quadrilateral inscribed within a circle, then the opposite angles are supplementary, or the opposite angles will total 180 degrees, right? They'll be supplementary. And the same, of course, is true for the other opposite angles. B and D together will total 180 degrees, or they are also supplementary to themselves. Okay? So that's the end of the lecture, and if you have any questions or concerns, as usual, please feel free to contact me at your convenience, and it would be my pleasure to help you. Okay? Bye-bye.